Welcome back. So let's talk about word embeddings. So the core problem that we want to solve is, again, we want to be able to process natural language documents. So we need to convert our words into some sort of numbers so that we can run it through a machine learning algorithm, for example. And we've seen some ways for doing this earlier. For example, we calculated the word frequency. Like here, we have some documents and we did the term frequency count. So like here, we just record all the words that appeared all across all the documents, and we simply recorded a count. And then this was a simple count vector. You've also seen that doing a simple count has various problems. In particular, you're losing the meaning of the text. If you look at these three documents here, each document has two sentences. Mary did kill John. Mary did not like to eat apples. Or John did not kill Mary. Mary did like to eat apples. Or Mary did not like to kill John. Mary did eat apples. If you're applying the simple count model for each of these three documents, you're going to get the exact same result. This is why it's called a bag of words model. You know, you're just looking at the words, like you put all of them in a bag, shake it, and then you just take out the words. So we are completely ignoring the order of the words and thereby lose the meaning of the original documents. So for some tasks, this is not so bad, but for other tasks, this is obviously not good. Now these three documents have very different meaning, very different semantics. Let's look at some other ways to encode the input. And one way is called the one-hot vector. So again, in one-hot vector, the dimensionality of the vectors is the size of the vocabulary. This is just like before. But now what we do is we encode a document word by word. So when we want to encode the sentence, the big dog, let's say our vocabulary size is 3, not realistic, but again, just to be able to visualize it. So we have 3 vectors. Each vector has 3 dimensions. And we have a 1 for the word if it appears, and a 0 for all the other words. So here we have a 1 for the, here we have a 1 for big, here we have a 1 for dog. So it's called one-hot vector because 1 is hot, and it's only hot for 1 value in the whole vector. So now we can encode the exact order of these 3 words. So it's this vector and this vector and this vector. So we don't lose information because we explicitly encode the position of the word in a longer document. But you can already see that for any kind of real-world scenario, this is just not practical. First, we don't just have 3 dimensions. In a real-sized vocabulary, we have a vector with thousands of dimensions. And then if you have a text with, I don't know, a few 100,000 words, then you have a few 100,000 vectors times thousands of dimensions. So this is just not practical. And there is another problem with this kind of representation, which in machine learning is known as the curse of dimensionality. So to understand why this is called the curse of dimensionality, there is again a small exercise on the worksheet. So what we're doing is we're taking 3 words, cat, dog, and house, and for each word, we choose a one-hot vector representation. So you can see again, we have a vector, which is hot, which has a value of 1 for the corresponding word. So go through task 4 on the worksheet, and then we're going to see what we can do about it.